I am Professor N.L. Oglapurkar, ex-Head of Physics Department, Garware College, Pune. Today and in the next lecture, I am going to explain some basic concepts and applications of electricity. The study of electricity begins with electrostatics. In the school days, we learn that a glass rod rubbed with silk acquires some new property. It can attract light bodies like a piece of paper. Same thing is true for ebonite rod rubbed with fur or cat skin. In this process, we say that some new physical quantity called charge or electric charge is developed on glass rod or ebonite rod. When experiments were performed, it was found that the charge on ebonite rod is opposite to that on the glass rod. Therefore, by convention, the charge on glass rod was called a positive charge, and the charge on ebonite rod is said to be a negative charge. When we come to know about the charges, the question arises, what are the properties of these electric charges? In secondary school days, you must have studied that the most basic property of electric charge is that like charges or similar charges repel each other and unlike charges attract each other. Now, what does it mean? First of all, there is some sort of interaction between electrical charges. Like charges repel, unlike charges attract. It means there is a force of repulsion or there is a force of attraction between electrical charges. So in this way, there is some sort of force. It is called interaction force between electrical charges. Obviously, next question is, how much is this force? On what factors does it depend? These aspects were investigated experimentally by scientist Coulomb. Therefore, the laws governing interaction force between electrical charges is called Coulomb's law. What is this Coulomb's law? You must have studied. The force between two prime charges Q1 and Q2 separated by distance r is given by Coulomb's law equation F. Now, because it is electrostatic force, let us call this FES. FES is K, constant of proportionality, multiplied by Q1 Q2 upon R square. Here, the value of proportionality constant K is 9 into 10 raised to 9 Newton meter square per Coulomb square. We assume that SI units are used throughout unless some other unit is mentioned. This value of K, 9 into 10 raised to 9, is true if the charges are kept in vacuum or merely in air. If the medium is something else, the value of constant K, proportionality constant K, will change. Many times, this equation for force between electrical charges is compared with gravitational force between two bodies, between two masses. I hope you know that the gravitational force of attraction between any two bodies is given by Newton's law of gravitation. The equation for Newton's law is F. That is gravitational force. So I have written here F gravitational. F gravitational is proportionality constant G multiplied by m1 m2 upon r square. G is called universal constant of gravitation. Its value is G equal to 6.67 into 10 raised to minus 11 SI unit Newton meter square per kilogram square. Now just compare the values of proportionality constant in Coulomb's law equation and in Newton's law equation. In electrostatic force, proportionality constant is 9 into 10 raised to 9. In equation for gravitational force, proportionality constant is 6.67 into 10 raised to minus 11. At once, you can understand that electrostatic force is much greater in magnitude than the gravitational force. For example, if you imagine two charges, each 1 coulomb, Q1 equal to Q2 equal to 1 coulomb, and imagine that they are separated by 1 meter distance. By using Coulomb's law equation, force between the two charges will be FES, electrostatic force, equal to 9 into 10 raised to 9 Newton. 9 into 10 raised to 9 Newton. How large is this force? For about 20 years, the tallest building in the world was supposed to be Empire State Building of New York. Now today there are many other taller buildings, but just for comparison, this 9 into 10 raised to 9 Newton force will be enough to lift the entire Empire State Building. See how huge is the force between two charges, each 1 coulomb separated by 1 meter distance. On the other hand, now what will be gravitational force under similar situations? Imagine two masses, each 1 kilogram, m1 equal to m2 equal to 1 kilogram, separated by distance 1 meter. Now by using Newton's law equation, the force, gravitational force, comes out to be 6.67 into 10 raised to minus 11 Newton. 10 raised to minus 11. Obviously the force is very weak. Once again, you realize that electrostatic force is much greater than the gravitational force. Let us see this in more precise manner. Let us consider electrostatic force and gravitational force between same bodies. Instead of bodies, now I will say particles. You know very well, hydrogen atom consists of 1 proton and 1 electron. Let us compare gravitational force and electrostatic force between these two particles, 1 proton and 1 electron. You know very well, the charge on proton is equal in magnitude to the charge in electron, denoted by E, small e. So, electrostatic force between proton and neutron will be FES equal to K, Q1, Q2 will become E square. So, K into E square upon R square. Now, how much is gravitational force between the same particles? F gravitational will be G. Now, instead of M1, M2, I have to say MP, mass of proton, into ME, mass of electron, divided by R square. Now, take the ratio of these two. I have written here, the ratio will be FES, electrostatic force, divided by F gravitational. After we divide the above two equations, what we get is K into E square divided by G, MP, mass of proton, into ME, mass of electron. We can put the known values. Values of K and G were already seen. electronic charge E is 1.6 into 10 raised to minus 19 coulomb. Mass of proton, mass of electron you can find easily from any book, from any table of physical constants. After we put the values and work out the calculation, the ratio of electrostatic force to gravitational force between proton and electron, this ratio comes out to be 2.4 into 10 raised to 39. Now once again you will realize how large is electrostatic force as compared to gravitational force. That's why your book says that electrostatic force is 10 raised to 39 times the gravitational force. Gravitational force is a weak force. Electrostatic force is much, much stronger. Here is activity for you. In Coulomb's law equation, we are written that K has value 9 into 10 raised to 9 Newton meter square per Coulomb square. How do you get that unit of K? Newton meter square per Coulomb square. Can you obtain that by using Coulomb's law equation? Okay. Now try the same method to obtain unit of thermal conductivity K. You are given an equation. For the present, don't bother what is that thermal conductivity. You learn in advanced classes. But at present, you can decide the unit of K from the equation that is given here. The equation is Q upon T equal to K A into d theta by dx. What are the different quantities? Q is quantity of heat. T is of course time. K is coefficient of thermal conductivity. A is area. D theta change in temperature. Dx distance. Now, you know units of all other quantities except K. Unit of Q is SI unit, joule. MKS unit or practical unit, calorie, kilocalorie. If you want SI unit, use joule. Unit of time is of course second, unit of area is meter square, unit of d theta, change in temperature. Whether we say change in temperature or temperature, unit is same. SI unit, Kelvin. Practical unit, degree Celsius. dx is distance, so unit is meter. So you know units of all other quantities and therefore you can determine unit of K. Try and write that. I need not say any more. In the same way, by using same method, you can obtain unit of coefficient of viscosity denoted by eta, Greek letter eta. For that, we are given the equation F equal to eta A dV by dx. Once again, for the time being, don't bother what is coefficient of viscosity. You will learn in the advanced class. Here our concern is whether you can obtain the unit or not, whether you can handle units. So in this equation, unit of force is of course Newton, unit of area is meter square, dV is change in velocity. Once again, unit will be same whether we say simple velocity or change in velocity. SI unit, meter per second. dx is distance, so unit is meter. So once again, you know units of all other quantities in this equation except eta. And therefore, you can write down unit of eta. Do that. I will not tell you anything more. Well, it will be interesting to compare Coulomb's law for force between electrical charges and Newton's law for force between two masses. See what are the similarities? First thing, electrostatic force proportional to product of charges Q1, Q2. Gravitational force proportional to product of masses M1, M2. In fact, considering this similarity, many times mass is called gravitational charge. Q is electric charge. Mass, gravitational charge. In magnetism, you have similar equation for force between two magnetic poles. There we can talk of magnetic charge. तेव्हा अशा प्रकारे आपण वेगवेगळ्या चार्ज बद्दल बोलू शकतो. Q हा झाला इलेक्ट्रिक चार्ज, मास त्याला म्हणता येईल ग्रॅव्हिटेशनल चार्ज, आणि मॅग्नेटिझम मध्ये मॅग्नेटिक पोलला मॅग्नेटिक चार्ज असं देखील म्हणता येईल. मॅग्नेटिझम मध्ये देखील अशाच प्रकारचं इक्वेशन आहे. दोन मॅग्नेटिक पोल्स मधला फोर्स हा त्या पोल्सच्या स्ट्रेंथला डायरेक्टली प्रपोर्शनल असतो. ठीक आहे, आता आपला विषय नाही येतो. ऍट प्रेझेंट वी आर नॉट कन्सिडरिंग दॅट. सो फर्स्ट सिमिलॅरिटी बिटवीन Coulomb's law equation and Newton's law equation. Electrostatic force proportional to Q1, Q2. Gravitational force proportional to M1, M2. Now the second similarity. Each force is proportional to 1 upon r square. Inverse square law. आपण इलेक्ट्रोस्टॅटिक फोर्स घेतला काय, ग्रॅव्हिटेशनल फोर्स घेतला काय, किंवा दोन मॅग्नेटिक पोल मधला फोर्स घेतला काय, त्या सगळ्या बाबतीत इन्व्हर्स स्क्वेअर लॉ आहे. फोर्स डिस्टन्सच्या स्क्वेअरला इन्व्हर्सली प्रपोर्शनल आहे. इन ईच केस F proportional to 1 upon r square. So there is a great similarity between equations for force between electrical charges, force between gravitational charges, that is masses, and force between magnetic charges, that is magnetic poles. या झाल्या similarities. इलेक्ट्रोस्टॅटिक फोर्स कुलॉम्स लॉने दाखवलेला आणि ग्रॅव्हिटेशनल फोर्स न्यूटन्स लॉने दाखवलेला. याच्यात काही अतिशय महत्वाचे फरक पण आहेत. इट इज नेसेसरी टू नोट द डिफरन्स बिटवीन कुलॉम्स लॉ अँड न्यूटन्स लॉ. See the differences here. First thing is electrostatic force can be either a force of attraction or force of repulsion, depending upon whether charges are similar or opposite. Electrostatic force attractionचा force असेल किंवा repulsionचा force असेल. But gravitational force is always force of attraction. It cannot be force of repulsion. Why? What is the reason? The equations are similar, but electrostatic force can be force of attraction or repulsion. On the other hand, gravitational force is necessarily force of attraction. कशामुळे हा फरक आला? Obviously, the difference is because there are two types of charges: positive charge, negative charge. We don't have two types of masses. Mass is mass. There is nothing like positive mass, negative mass. So, gravitational force is necessarily a force of attraction. Charges दोन प्रकारचे असतात, पॉझिटिव्ह, निगेटिव्ह. पण मास मात्र एकाच प्रकारचा आहे. असं आपण म्हणत नाही एकाच प्रकारचा आहे. मास हे फक्त मास आहे. तर ते पॉझिटिव्ह, निगेटिव्ह असे दोन प्रकार नाही आहेत. आणि म्हणून हा महत्वाचा फरक आहे. This is the second difference. Electrostatic force between charges Q1 and Q2 depends upon medium between the charges. मगाशी मी सांगितलं की दोन चार्ज मधलं मीडियम व्हॅक्यूम किंवा एअर असेल तर K ची व्हॅल्यू आहे 9 into 10⁹. पण इतर काही मीडियम असेल तर प्रपोर्शनॅलिटी कॉन्स्टंटची व्हॅल्यू बदलेल. सो electrostatic force depends upon medium between the charges. On the other hand, gravitational force does not depend upon medium. Force between masses M1 and M2 remains same, whatever be the medium between the masses. त्याचंच एक उदाहरण या ठिकाणी तिसरा पॉइंट दाखवलाय. Imagine that there is a metal plate between two charges Q1 and Q2. Now what will happen to force between Q1 and Q2? The force will be clean, zero. मेटल प्लेट असेल तर Q1 Q2 चार्ज मध्ये फोर्स अजिबात नाहीये. द फोर्स व्हॅनिशेस. म्हणजेच काय, मेटल प्लेट मुळे Q1 Q2 चार्ज एकमेकापासून एकमेकाच्या प्रभावातून मुक्त झालेले आहेत. जणू काही Q1 Q2 मध्ये पडदा टाकलेला आहे. सो वी से दॅट electrostatic force can be screened. Q1 Q2 charges are screened by the metal plate. There is no more any force between Q1 and Q2. But gravitational force does not depend upon medium. So gravitational force cannot be screened. तर हे महत्वाचे फरक लक्षात ठेवायचे. Remember these important differences between force between electrical charges given by Coulomb's law and force between masses given by Newton's law. I think this discussion about electrostatics should be enough for the time being. Let us go to some other aspect of electricity, some other topic. When we come to study electric current electricity, we have to talk of conductors and insulators. After all, what is electric current? Electric current is continuous motion of free electrons. As soon as there is potential difference between two ends of a conductor, a continuous flow of electrons is set up in the conductor, and we say there is an electric current. So what forms current? Current is formed by continuous motion of free electrons. Of course, you know that direction of conventional current is opposite to the direction in which electrons are moving. Therefore, in order to obtain an electric current, what is necessary? One thing, of course, potential difference. But then, what is necessary is motion of free electrons. So, free electrons must be there. Unless there are free electrons, there cannot be any motion, even though there is potential difference. तेव्हा इलेक्ट्रिक करंट मिळण्यासाठी पहिल्यांदा फ्री इलेक्ट्रॉन्स असले पाहिजेत. ती फ्री इलेक्ट्रॉन काय बनणार आहे? What is free electron? Electrons are there in every material. You know very well that all the matter consists of atoms and molecules. In each atom, electrons are moving around the nucleus. An electron moving around the nucleus is a bound electron. The electron is not free to go anywhere. It has to move around the nucleus in a circular orbit. तर ऍटम मधला न्यूक्लियस भोवती फिरणारा जो इलेक्ट्रॉन आहे तो काही फ्री इलेक्ट्रॉन नाहीये. In metals, what happens is one of the valence electrons overcomes binding of the atom. It leaves the atom and then it can move anywhere within the metal. This is called free electron. मेटल मध्ये प्रत्येक ऍटमच्या व्हॅलन्स इलेक्ट्रॉन पैकी एक इलेक्ट्रॉन त्या ऍटमला सोडून बाहेर पडतो. आणि जर तो बाहेर पडला की तो काही त्या न्यूक्लियर भोवती फिरत राहत नाही. तो त्या मेटल मध्ये कुठेही इकडे तिकडे हिंडू शकतो. सो दिस इज कॉल्ड फ्री इलेक्ट्रॉन. अँड मोशन ऑफ दीज फ्री इलेक्ट्रॉन्स कॉन्स्टिट्यूट्स इलेक्ट्रिक करंट. So, now it is clear that to set up an electric current, free electrons must be present. Any material that contains plenty of free electrons is a good conductor because current can easily flow. ज्याच्यामध्ये असंख्य फ्री इलेक्ट्रॉन्स आहेत तो गुड कंडक्टर. करंट पोटेन्शियल डिफरन्स आला की लगेच त्या असंख्य फ्री इलेक्ट्रॉनची मोशन सुरू होणार आहे. उदाहरणार्थ कॉपर मध्ये किती फ्री इलेक्ट्रॉन्स आहेत? 10⁻29 free electrons in 1 meter cube. That is in unit volume. 10⁻29. Imagine how huge is the figure. So any metal is an ocean of free electrons, and therefore it is a good conductor. On the other hand, in materials like glass, mica, paper, wood, etc., free electrons are not there. Electrons are there, but each electron is simply moving around the nucleus. All the electrons are bound to the respective atoms. तर हे जे मटेरियल आहेत, ग्लास, मायका, पेपर, यांच्यामध्ये फ्री इलेक्ट्रॉन अजिबात नाही आहेत. सगळे इलेक्ट्रॉन आपापल्या न्यूक्लियस भोवती फिरण्यामध्ये गरक आहेत. कुठला इलेक्ट्रॉन फ्री नाहीये. त्यामुळे जरी बॅटरी कनेक्ट केली, इवन द there is potential difference, there cannot be any electric current. Motion of free electron does not exist because free electrons are not there at all. Such materials are called bad conductors or good insulator. I use the word bad. Let us say good insulator. So what is the difference between conductors and insulators? Any material that contains plenty of free electrons, ocean of free electrons, is a good conductor. A material that does not contain free electrons is an insulator. Yes, of course. I will think that there are some other materials like silicon which are neither a good conductor nor bad conductor. In materials like silicon, germanium, and there are some others, free electrons are there, but not as many as in case of metals. Number of free electrons is much smaller than in case of good conductors. For example, here I have given the figure for silicon. In silicon, there are 10⁻16 free electrons per unit volume. This is at room temperature, so I have said 300 Kelvin. 10⁻16 free electrons per unit volume. कॉपर मध्ये किती आहे? 10⁻29. सिलिकॉन मध्ये 10⁻16. लाखो पटीने स्मॉलर. लाखो फार लहान नंबर येईल. व्हेरी मच स्मॉल as compared to copper or any good conductor. So material like silicon or germanium is a semiconductor. It is neither a good conductor nor bad conductor. This is what we can say about conductors and insulators. Next, when we think of electric current, first concept that arises is resistance. What is this resistance? How does it arise? Let us think. मगाशी मी म्हणलो की प्रत्येक मेटलमध्ये असंख्य फ्री इलेक्ट्रॉन्स आहेत. फ्री म्हणजे काय? तो इलेक्ट्रॉन त्या ऍटमला बांधलेला नाहीये. इलेक्ट्रॉन इज बाउंड टू द ऍटम. The electron can move within the metal. Does it always move? Yes, it always moves. Electron can never stop at a position. It is moving. What type of motion it describes? Normally. Normally means in absence of potential difference, in absence of electric field, electron describes a random motion. इलेक्ट्रिक फील्ड नसताना इलेक्ट्रॉनची गती ही वेडी वाकडी झिगझॅग इतस्ततः म्हणता येईल अशा प्रकारची आहे. या फिगर मध्ये सॉलिड लाईननी दाखवलेली आहे. ए पासून इलेक्ट्रॉन सुरू झाला तो इथे गेला. अशा प्रकारे इलेक्ट्रॉनच्या मोशन मध्ये तो इलेक्ट्रॉन दुसऱ्या एका ऍटमवर आपटतो. There is a collision between electron and atom. Of course, when I say an electron becomes free, the remaining part of the atom after one electron leaves, obviously that atom will become a positive ion. So in metal there are as many positive ions as many free electrons. Ocean. But the free electrons move, whereas atoms or positive ions have fixed positions. They cannot move. They simply vibrate, but they cannot leave their position. So in this figure, imagine an electron starting from A. It moves. After some motion, it collides here with a copper atom, with a positive ion. At each collision, the direction of motion will change. Now electron starts moving in some other direction. Now it moves here. It collides again with another atom. Again its direction changes, it moves like this, again like this, then it goes here, and so on. So अशा प्रकारे इलेक्ट्रॉनची वेड्यावाकड्या दिशेने झिगझॅग पद्धतीने मोशन एकसारखी चालू आहे, नॉन स्टॉप. Electron is continuously moving along random directions. Its average position does not change. Initial position is A, final position is B. It's not much different. After thousands of such collisions, electron may come back to A, or it will be near about the same position. तो अशा प्रकारे जरी इलेक्ट्रॉनची रॅन्डम मोशन चालू असली तरी त्याची जागा काही बदलत नाहीये, त्याच जागी फिरतोय म्हणलं तरी चालेल. Now what happens after we connect the battery? When there is potential difference between the ends of a conductor, an electric field is set up within the conductor. Electric field will produce force on the electron. Force produces acceleration. Acceleration means velocity goes on increasing. It means kinetic energy goes on increasing. So now what will be motion of electron? Random motion is still there. But along with random motion, there is some systematic motion. The motion is in a direction opposite to that of the electric field. In the same figure, motion of electron in presence of electric field is shown by broken line, dotted line. So starting from A, electron goes here, collides with an atom. Then it goes here, again collides with an atom, and so on. So in this way, after few collisions, electron starting from A comes to position B1. जर पोटेन्शियल डिफरन्स नसतं तर इलेक्ट्रॉन ए कडून बी कडे आला असता, पण तेवढ्याच वेळात तेवढीच कोलिजन झाल्यानंतर पोटेन्शियल डिफरन्स असल्यामुळे इलेक्ट्रॉन ए कडून B1 कडे आलेला आहे. So we say that there is a drift of the electron from B to B1. त्या ठिकाणी रॅन्डम मोशन आहे, पण त्या रॅन्डम मोशन बरोबर इलेक्ट्रॉन उजवीकडे चाललेला आहे. त्या ठिकाणी आपण गृहीत धरले की इलेक्ट्रिक फील्ड डावीकडे, इलेक्ट्रॉनची गती उजवीकडे, इलेक्ट्रिक फील्डच्या विरुद्ध दिशेने. तेव्हा बी पासून B1 पर्यंत इलेक्ट्रॉन सरकलेला आहे, त्याला ड्रिफ्ट म्हणतात, ड्रिफ्ट. So now there is some drift motion along with random motion. Remember, what is the actual distance traveled by the electron? Starting from A, electron goes here, then here, then here, then here, and so on. So actual distance traveled can be quite large. What is the drift motion? How much distance electron moves effectively only from B to B1. तेव्हा इलेक्ट्रॉननी प्रत्यक्ष कापलेलं अंतर आणि ड्रिफ्ट मोशननी गेलेलं अंतर याच्यामध्ये अतिशय फरक आहे. रॅन्डम मोशन ऑफ इलेक्ट्रॉन टेक्स प्लेस विथ व्हॉट स्पीड? It is something like 10⁶ meter per second, 1000 kilometer per second. इलेक्ट्रॉनच्या रॅन्डम मोशनचा स्पीड अतिशय मोठा आहे, दर सेकंदाला 1000 किलोमीटर, 10⁶ मीटर पर सेकंड. आणि याच्या उलट ड्रिफ्ट मोशनचा स्पीड किती आहे? अतिशय लहान. ड्रिफ्ट मोशनचा स्पीड तासाला 1-2 मिलीमीटर, रॅन्डम मोशनचा स्पीड सेकंदाला 1000 किलोमीटर आणि ड्रिफ्ट मोशनचा स्पीड फक्त millimeter per hour. So the speed of drift motion can be or is really extremely small, only few millimeter per hour, and speed of random motion is 10⁶ meter per second. You will be surprised if the drift speed is so small. How is it that an electric bulb or any electric appliance works as soon as we turn the switch on? इलेक्ट्रॉनचा ड्रिफ्ट स्पीड अतिशय कमी आहे, तासाला 1-2 मिलीमीटर. मग आपण बटन दाबल्यावर लगेच बल्ब लागतो, लगेच ट्यूबलाईट लागते किंवा लगेच हीटर गरम होतो. कुठलाही इलेक्ट्रिकल अप्लायन्स, इलेक्ट्रिक उपकरण लगेच चालू होतं. हे कसं काय? इलेक्ट्रॉनचा स्पीड तर तासाला काही मिलीमीटर आहे. या ठिकाणी इलेक्ट्रॉनच्या ड्रिफ्टचा काही संबंध नाहीये. उदाहरणार्थ इलेक्ट्रिक बल्ब घेतला की त्या बल्बची जी टंगस्टन फिलामेंट आहे, टंगस्टनची वायर आहे, त्यात करंट आला की लगेच बल्ब पेटणार, लगेच बल्ब मधून प्रकाश बाहेर पडणार. मग त्या फिलामेंट मधल्या इलेक्ट्रॉनची मोशन केव्हा सुरू होती? असं नाही की आपण बटन दाबलं की त्या बटनातले इलेक्ट्रॉन त्या बल्ब मध्ये आले, असं नाही. त्या फिलामेंट मध्ये इलेक्ट्रॉन आहेतच. मेटल मध्ये सर्वत्र असंख्य फ्री इलेक्ट्रॉन असतात. मग त्यांची मोशन कशी सुरू होणार आहे? मोशन ऑफ फ्री इलेक्ट्रॉन्स starts as soon as there is electric field. When you switch on, you are producing electric field. This electric field travels in the conductor with velocity of light. Electric field एका ठिकाणी आपण अप्लाय केलं की दुसरीकडे पोहोचायला किती वेळ लागतो? काही वेळ लागत नाही. इलेक्ट्रिक फील्ड एका ठिकाणाहून दुसऱ्याकडे जाण्याच्या स्पीड किती? व्हेलॉसिटी ऑफ लाईट 3 × 10⁸ मीटर पर सेकंड. तर तुम्ही बटन दाबलं की इलेक्ट्रिक फील्ड निर्माण झालं. ते त्या बल्बच्या फिलामेंट पर्यंत पोहोचायला किती वेळ लागणार आहे? काहीच वेळ लागणार नाहीये. कारण इलेक्ट्रिक फील्ड जाण्याची व्हेलॉसिटी लाईटच्या व्हेलॉसिटी इतकी आहे. सो डोंट वेट टिल इलेक्ट्रॉन्स ऍट द स्विच move to the filament of the bulb. No. Now you will understand that how the bulb turns on as soon as you put the switch on, although the drift speed is very, very small. या ठिकाणी एक ऍक्टिव्हिटी आहे, याच्यावर आपल्याला ड्रिफ्ट स्पीडचं प्रत्यक्ष कॅल्क्युलेशन करता येईल. इन दिस सेकंड ऍक्टिव्हिटी you can work on actual drift speed. You have some realistic data here. Realistic. These are true figures, not imaginary figures. And you can calculate the drift speed. For that, equations are given to you. So in this activity, we imagine 1 ampere current in a copper wire. Area of cross section of copper wire is 2 millimeter square. How many electrons are there? 1 centimeter cube of copper contains how many electrons? 8.5 into 10⁻22 2 electrons. हा डाटा वापरून आपल्याला इलेक्ट्रॉनचा ड्रिफ्ट स्पीड कॅल्क्युलेट करता येईल. You can use this data to calculate drift speed of electrons. We have some simple equation. Here we introduce a quantity called current density. Electric current flowing per unit area is called current density. Current density denoted by J. J is I upon A. Current flowing per unit area. या ठिकाणी करंट दिलाय 1 एम्पियर, एरिया ऑफ क्रॉस सेक्शन दिले 2 मिलीमीटर स्क्वेअर. कॅल्क्युलेशन करताना SI युनिट मध्ये क्वांटिटीज घ्याव्या लागतील, सहजपणे घेता येतील. करंट डेन्सिटी आणि ऍडव्हान्स फिजिक्स मध्ये करंट डेन्सिटी साठी फॉर्म्युला आहे. इक्वेशन फॉर करंट डेन्सिटी इज करंट डेन्सिटी J is NeV suffix D. N number of electrons per unit volume. It is given here. N is given. You have to convert into SI unit. E is of course electronic charge. You know very well. E has value 1.6 into 10⁻⁻19 coulomb. Vd is drift velocity. So you can use this equation and calculate drift velocity. You will find that drift velocity is small fraction of millimeter per second. तेव्हा हे इक्वेशन दिलंय, व्हॅल्यूज दिलेले आहेत, तुम्हाला इलेक्ट्रॉनची ड्रिफ्ट व्हेलॉसिटी कॅल्क्युलेट करता येईल. कॅल्क्युलेशन केल्यानंतर लक्षात येईल की ड्रिफ्ट व्हेलॉसिटी किती लहान आहे, 1 मिलीमीटर पेक्षा खूपच कमी, स्मॉल फ्रॅक्शन ऑफ मिलीमीटर पर सेकंड. बघा कॅल्क्युलेशन करून. आपली ही चर्चा कशाकडे चालली होती, कन्सेप्ट ऑफ रेझिस्टन्स. तुम्ही म्हणाल की रेझिस्टन्स सांगता हे मध्ये ड्रिफ्ट कुठून आला. दीज थिंग्स आर related. In fact, resistance arises because of random motion of free electrons. So let us once again come to electric current in a conductor. When a potential difference is present between two ends of a conductor, it does not happen that electrons travel from one end to other end along straight line path. No. Electron cannot move very easily. Why? Because it has to collide with copper atoms. During this motion, electrons have to collide. At each collision, entire kinetic energy of electron is given to the atom. So electronचं copper atomशी collision झालं की त्याची kinetic energy संपली. ती सगळी एनर्जी त्या कॉपर ॲटमला दिली. इलेक्ट्रॉनला परत पहिल्यापासून सुरू करायला पाहिजे, परत त्याची वेलॉसिटी वाढत जाणार आहे. कशामुळे वेलॉसिटी वाढणार आहे, पोटेन्शियल डिफरन्स मुळे इलेक्ट्रिक फील्ड मुळे फोर्स मुळे ऍक्सिलरेशन म्हणजेच इन्क्रीज इन स्पीड. तेव्हा प्रत्येक कोलिजनला त्याचा स्पीड झिरो होतो. परत स्पीड वाढत गेला म्हणजेच कायनेटिक एनर्जी वाढत गेली. पुढचं कोलिजन झालं की परत कायनेटिक एनर्जी संपली, परत पहिल्यापासून सुरुवात. So at each collision, electron has to start once again. Its velocity goes on increasing, kinetic energy increases, and as soon as there is collision, all that kinetic energy is lost. It is given to the atom. त्या ॲटमला कायनेटिक एनर्जी मिळाली म्हणजेच ॲटमची व्हायब्रेशन जास्त जोरात सुरू झाली आणि याचाच अर्थ त्या कंडक्टरचं टेम्परेचर वाढलं. दिस एक्सप्लेन्स heating effect of electric current. Anyway, for the time being, we are concerned with electron. So how is the motion of electron? Not very smooth. At each collision, it has to lose all the kinetic energy and start fresh. एकूण काय झालं, त्या कोलिजन मुळे इलेक्ट्रॉनची मोशन काही सहजपणे होऊ शकत नाही. इलेक्ट्रॉनच्या मोशनला अडथळा आहे. There is a sort of hindrance to motion of electrons. There is opposition to the flow of current. आणि ह्यालाच आपण म्हणतो resistance. So why there is a resistance? Because each free electron has to undergo several collisions in moving through the conductor. Resistance arises because of this. How many collisions? How much time passes between two successive collisions? Here are some typical figures in case of copper. In case of copper, what is the average time between two successive collisions? See how small it is. 2.5 into 10 raised to minus 14 seconds. Very small. How much distance the electron travels between two successive collisions? 4 into 10 raised to minus 8 meter. This is figure for copper. कोलिजन किती बराबर होतात लक्षात घेत. इतक्या कमी अंतरात एक कोलिजन होणार आहे. And between two successive collisions, electron crosses about 150 copper atoms. तर आता लक्षात येईल की रेझिस्टन्स कशामुळे आला. Why there is a resistance? There is resistance because motion of electron is opposed. Motion of electron is hindered due to collisions with atoms of the conductor. After you learn about resistance, your book will give some simple equations. The resistance of a conductor depends upon length, directly proportional to length. It is inversely proportional to area of cross section. And so we have this simple equation for resistance of a conductor. Resistance R equal to some proportionality constant rho into L length upon A area of cross section. The proportionality constant rho is a property of the material. This property is called specific resistance. Other name, it is also called resistivity. तो ह्या इक्वेशन मधला जो प्रपोर्शनॅलिटी कॉन्स्टंट रो आहे त्याला म्हणायचं त्या मटेरियलची रेझिस्टिव्हिटी म्हणजेच स्पेसिफिक रेझिस्टन्स. परत एकदा मग असता गुड कंडक्टर, इन्सुलेटर, मगाशी जे काय सांगितलं त्यावरून ताबडतोब लक्षात येईल की गुड कंडक्टरसाठी हा स्पेसिफिक रेझिस्टन्स अतिशय कमी असतो. The specific resistance has very small value in case of good conductor. Typical values are given here. In case of copper, rho, specific resistance is 10 raised to minus 8. It's a unit per meter. So every metal, every conductor will have such a small value for rho. Actual values can be different, but order is 10 raised to minus 8. On the other hand, bad conductor or insulator will have very large value of rho, specific resistance. Excellent insulator is mica. In case of mica, rho has value 10 raised to plus 14 ohm meter. Compare copper साठी rho ची value 10 raised to minus 8 आणि mica साठी rho ची value 10 raised to plus 14. तर इन्सुलेटर साठी किंवा बॅड कंडक्टर साठी रो अतिशय मोठा आणि गुड कंडक्टर साठी रो अतिशय लहान. Obviously, a semiconductor like silicon will possess intermediate value of rho, intermediate, somewhere between the value of rho for good conductor and that for bad conductor. In case of silicon, rho has value 600 ohm meter at room temperature. मग आजपासून at room temperature म्हणतोय कारण काय तर हा जो रेझिस्टन्स आहे किंवा स्पेसिफिक रेझिस्टन्स आहे त्याची व्हॅल्यू टेम्परेचर अवलंबून आहे. स्पेसिफिक रेझिस्टन्स अँड हेन्स रेझिस्टन्स डिपेंड्स अपॉन टेम्परेचर, व्हॅरीज विथ टेम्परेचर. तर हा जो स्पेसिफिक रेझिस्टन्स आहे हा टेम्परेचर प्रमाणे बदलत जातो. In case of metals, rho increases slightly with increasing temperature. Temperature वाढलं की मेटलचा रेझिस्टन्स किंवा रो किंचित वाढतो. On the other hand, resistance of a semiconductor has exaggerated variation with temperature. Exaggerated. Semiconductorच्या बाबतीत टेम्परेचर डिफरन्स खूपच मोठा आहे. कंडक्टरला रेझिस्टन्स किंचित वाढतो पण सेमीकंडक्टरचं उलट आहे. टेम्परेचर वाढलं की सेमीकंडक्टरचा रेझिस्टन्स कमी होतो आणि कमी होतो काय किंचित नव्हे खूप मोठ्या प्रमाणात कमी होतो. That's why I have written here in case of semiconductors, rho, specific resistance, decreases to a large extent with increasing temperature. So, to summarize, in case of conductors, rho increases slightly when temperature increases. On the other hand, in case of semiconductors, rho decreases to a large extent when temperature is increased. या ठिकाणी आणखी एक ऍक्टिव्हिटी, व्हेरी सिंपल ऍक्टिव्हिटी हियर. You must have read this equation in your textbooks. When current passes through a conductor, every conductor has some resistance, heat is produced. How much heat is produced? Heat produced by electric current is given by Joule's law or Joule's equation H equal to I square RT. In this, I is current, R is resistance and T is time. H is heat energy produced. When I say heat energy, SI unit will be joule. Possibly in your books, the equation might be H equal to I square RT upon J. Upon J, J will come there if you want calories. आपल्याला SI युनिट वापरायचं असेल जूल तर J ची आवश्यकता नाही, नुसतं I square RT. जर कॅलरी मध्ये किंवा किलो कॅलरी मध्ये हीट पाहिजे असेल तर इक्वेशन विल I square RT upon J. Anyway, so in this activity, use this equation and calculate how much heat energy is produced in 1 minute when 3 ampere current passes through a nichrome wire having resistance 20 ohm. Micro electric heater किंवा इलेक्ट्रिक आयर्न इस्त्री याचं हिटिंग एलिमेंट नायक्रोमचं असतं. नायक्रोम काय आहे? अलॉय आहे आणि नावाप्रमाणेच नायक्रोम म्हणजे निकेल आणि क्रोमियम. निकेल आणि क्रोमियम यांचा अलॉय हा हिटिंग एलिमेंट साठी पॉप्युलरली वापरला जातो आणि तो निकेल क्रोमियमचा अलॉय नायक्रोम. Calculation is pretty simple. You can work out the calculation in few seconds. तशीच आणखी ऍक्टिव्हिटी दिलेली आहे. It is pretty simple. I think I need not explain anything. मला असं इक्वेशन घेतलं तर लगेच लक्षात येईल. Yes, equation for changing resistance with temperature R suffix T is R0 into 1 plus alpha T. आपल्या पुस्तकात आहे इक्वेशन, त्यामुळे मी इथे काही दिलं नाहीये, सगळ्या पुस्तकात हे इक्वेशन दिलेलं आहे. So you can calculate resistance at any temperature. आणि नुसताच रेजिस्टन्स काढण्यासाठी मग असा फॉर्म्युला R equal to rho L upon A. तर ह्या 2-3 ऍक्टिव्हिटी काही सांगण्याची जरूर नाही, सगळे सिंपल आहे, सहज कॅल्क्युलेशन करता येईल. पुढचा पॉइंट एक सांगतो, सुपर कंडक्टिव्हिटी. रिसेंट टॉपिक, इंटरेस्टिंग टॉपिक. In 1911, famous scientist Kamerlingh Onnes is Nobel laureate. He was awarded Nobel Prize. Kamerlingh Onnes found that resistance of mercury becomes zero when it is cooled below 4 degree Kelvin or Kelvin. In general, for many materials, for most materials, resistance decreases when temperature is decreased. Resistance not only decreases, but resistance becomes absolutely zero, clean zero, not nearly zero. In some books it is called nearly zero, it is not correct. So for many materials, resistance becomes zero, precisely zero, when cooled below a certain temperature Tc. This Tc is called critical temperature. काही मटेरियल गार केल्यानंतर विशिष्ट टेम्परेचरला त्याचा रेजिस्टन्स झिरो होतो. हे जे टेम्परेचर टीसी आहे त्याला म्हणलं क्रिटिकल टेम्परेचर. रेजिस्टन्स झिरो हा एक चमत्कार आहे म्हणलं तरी चालेल. रेजिस्टन्स झिरो म्हणजे काय? देयर इज नो ऑपोजिशन टू द फ्लो ऑफ करंट, सो करंट कॅन फ्लो इझिली. इलेक्ट्रिक करंटला काहीच एनर्जी लागणार नाहीये, करंट फ्लोच नाहीये, रेजिस्टन्सच नाहीये. So once electric current is set up, to set up the electric current, battery will be required. Resistance is zero, so current can be thousands of ampere. And now you remove that battery. आता बॅटरी काढून टाकली तरी तो 100 अँपियर 1000 अँपियर करंट त्या कंडक्टर मध्ये राहणार आहे, तो कधीच कमी होणार नाहीये, कारण रेजिस्टन्स झिरो आहे, ऑपोजिशन नाहीच आहे. सो करंट कॅन परसिस्ट फॉर अ लॉंग टाइम. लॉंग टाइम मीन्स हाऊ लॉंग? फॉर सेव्हरल इयर्स, indefinitely. So in this way, current can persist in a conductor. Huge current, 100 ampere, 1000 ampere, can persist in a conductor even if the battery is removed. That means without requiring energy. म्हणून याला म्हणतात superconductor. This is called superconductivity. Resistance becomes zero, so large current can persist for a very long time, several years, without requiring source of EMF, without requiring any energy. This is called superconductivity. normal conductivity and superconductivity are different. Quite different. The reason is, excellent conductors like copper, silver, they never become superconductor. Even if copper is cooled to any low temperature, it never becomes superconductor. On the other hand, there are many ceramic materials which become superconductor, but at ordinary temperature they are excellent insulators. अनेक ceramic material आहेत ते नेहमीच्या टेम्परेचरला बाहेर कंडक्टर आहेत, इन्सुलेटर आहेत. पण विशिष्ट टेम्परेचरला गार केल्यानंतर मात्र त्याचा रेजिस्टन्स 0 होतो, सुपरकंडक्टर. याच्यावर लक्षात येईल की कंडक्टिव्हिटी आणि सुपर कंडक्टिव्हिटी त्या दोन्ही अगदी वेगळ्या गोष्टी आहेत. लुक ॲट दीज ग्राफ्स. ग्राफ ऑफ रेझिस्टिव्हिटी रो अगेन्स्ट टेम्परेचर T. See the graph for decreasing temperature. For a normal material, when temperature is decreased, resistance decreases. Resistance goes on decreasing, but it never becomes 0. Even though temperature is 0, resistance is there. This is normal material. Now look at the graph for superconductor. Resistance, when material is cooled, resistance goes on decreasing, and at some temperature, the resistance suddenly becomes 0. Here, you can see that resistance suddenly drops to 0. This is superconductor. Superconductivity has many applications, very useful applications. For power transmission from generating station to city, we use superconductor. There will be no loss of energy, no loss of electric power. Very useful. I have given here many applications. You can see easily. Very fast computer switches can be obtained with the help of superconductors. Very powerful magnets used for material science can be obtained using superconductor. तर सुपरकंडक्टर मध्ये आत्ता तरी एकच अडचण आहे, त्याला अनेक ऍप्लिकेशन्स आहेत. आत्ता तरी एकच अडचण आहे की सुपरकंडक्टिव्हिटी ही फार लो टेम्परेचर जायला लागतं, आपल्याला ऍब्सोल्यूट 0 जवळ जायला लागतं. सायंटिस्ट नवीन नवीन मटेरियल शोधायच्या प्रयत्नात आहेत आणि आत्ता तरी सुपरकंडक्टिव्हिटी 160 केल्विन, नॉर्मल टेम्परेचर काय 273 केल्विन, एवढं फुल केलं की आपल्याला सुपरकंडक्टर मिळतो. पण येत्या 5 वर्षात असं काही मटेरियल तयार होईल की जे रूम टेम्परेचरला सुपरकंडक्टर आहे आणि आपल्याला अनेक चमत्कार पाहायला मिळतील. We'll have many interesting applications. I think this is enough for today. In our next lecture, I will tell you much more useful things about electricity. Not only that, we will solve problems. Goodbye till that.